the United States, the National Electrical Code, referred to as NEC, limits the number of branch circuits that can be installed in a single electrical panel to 40. This rule applies to both residential and commercial applications. The NEC 40 circuit rule is primarily based on safety considerations. Firstly, circuit overload. Limiting the number of circuits in a panel reduces the risk of circuit overloads, which can cause overheating and electrical fires. Secondly, voltage drop. Too many circuits connected to a single panel can cause excessive voltage drop, which can affect the performance of electrical devices and equipment. Thirdly, equipment space. Panels with more circuits require more space for wires and terminals, which can compromise accessibility and safety. The 40 circuit rule can have significant implications for electricians in the United States. For houses with a large number of circuits, electricians must install multiple electrical panels to meet the NEC requirement. This can add to the cost and complexity of the electrical system. Electricians need to work closely with architects and builders to plan the electrical layout to ensure sufficient panel capacity while adhering to the NEC rule. In some cases, electricians may consider using subpanels or other solutions to accommodate additional circuits beyond 40. The 40 circuit rule is unique to the United States. In Canada, the electrical code does not impose a specific limit in the number of circuits in a panel, allowing for the installation of panels with more than 40 circuits. There are advantages and disadvantages to the 40 circuit rule. Advantages include enhanced safety by reducing the risk of overloads and voltage drop. Disadvantages can include the need for multiple panels in large houses, increasing cost and complexity, and may limit flexibility in electrical system design. The 40 circuit rule has been criticized by some electricians who argue that it is overly restrictive and does not take into account advancements in electrical technology. However, the NEC maintains the rule based on concerns over safety and reliability. Overload protection is crucial in electrical panels to prevent damage and hazards. Circuit breakers and fuses are the primary devices used for this purpose. A circuit breaker is a reusable device that automatically interrupts the flow of electricity when it detects an overcurrent or short circuit. It consists of a bimetallic strip or an electromagnet that trips the breaker, opening the circuit. Fuses, on the other hand, are one-time use devices that contain a metal filament that melts and breaks the circuit when an overcurrent occurs. Fuses must be replaced after they blow. The NEC provides detailed guidelines on the selection and installation of overcurrent protection devices. For example, NEC Section 240.4 covers the protection of conductors against overcurrent, specifying that conductors must be protected by overcurrent devices rated in accordance with their ampacity. Ampacity refers to the current carrying capacity of a conductor, which is determined by factors such as the conductor's material, size, insulation type, and the ambient temperature. Voltage drop is another critical consideration in electrical panel design. Excessive voltage drop can lead to dimming lights, malfunctioning equipment, and reduced energy efficiency. The NEC recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. Several factors contribute to voltage drop, including the length of the circuit, the size of the conductors, and the amount of current flowing through the circuit. To minimize voltage drop, electricians can use larger conductors, shorten circuit lengths, or increase the voltage at the source. Calculations for voltage drop are typically performed using Ohm's law and other electrical formulas. Proper grounding and bonding are essential for electrical safety. Grounding provides a low impedance path for fault current to return to the source, allowing overcurrent protection devices to quickly trip and clear the fault. Bonding connects all metal parts of the electrical system together, ensuring that they are at the same electrical potential. The NEC specifies detailed requirements for grounding and bonding, including the use of grounding electrodes, grounding conductors, and bonding jumpers. Grounding electrodes, such as ground rods or ground plates, are used to connect the electrical system to the earth. Grounding conductors carry fault current back to the source. Bonding jumpers connect metal parts of the electrical system together. Proper wiring techniques are also crucial for electrical safety and reliability. Wires must be properly sized, insulated, and connected to prevent overheating, shorts, and other hazards. The NEC provides detailed guidelines on wiring methods, including the types of cables and conductors that can be used in different applications. For example, NEC Article 310 covers conductors for general wiring, specifying the types of insulation, opacity, and other requirements. Wiring connections must be made using approved methods such as wire connectors, terminals, or soldering. Wire connectors must be properly sized and installed to ensure secure and reliable connection. Electrical panels must be properly labeled to identify the circuits they serve. This helps electricians and homeowners quickly locate and disconnect circuits for maintenance or repairs. The NEC requires that each circuit breaker or fuse be clearly labeled with a description of the load it serves. Panel schedules are often used to provide a detailed listing of the circuits in the panel. The panel schedule should include the circuit number, the description of the load, the size of the overcurrent protection device, and any other relevant information. Regular maintenance of electrical panels is essential for ensuring their continued safe and reliable operation. Maintenance tasks include inspecting for loose connections, corrosion, and other signs of damage. Circuit breakers should be tested periodically to ensure that they are functioning properly. The panel should also be kept clean and free of debris. The NEC recommends that electrical panels be inspected by a qualified electrician at least once a year. Electrical safety is paramount when working with electrical panels. Always to energize the circuit before working on it. Use insulated tools and wear appropriate personal protective equipment, such as gloves and safety glasses. If you are not comfortable working with electrical panels, hire a qualified electrician to do the job. The NEC provides detailed requirements for electrical safety, including lockout/tagout procedures, arc flash protection, and other safety measures. Lockout/tagout procedures are used to ensure that circuits are de-energized before work is performed. Arc flash protection is used to protect workers from the hazards of arc flash, which is a dangerous electrical explosion. Here are some additional considerations for electrical panel design and installation. Firstly, consider the future needs of the electrical system. Install a panel with sufficient capacity to accommodate future loads. Secondly, choose a panel that is appropriate for the environment. For example, use a weatherproof panel in damp or outdoor locations. Thirdly, ensure that the panel is properly ventilated to prevent overheating. Fourthly, install surge protection devices to protect sensitive electronic equipment from voltage spikes. Fifthly, use arc fault circuit interrupters, or RFCs, to protect against arc faults, which can cause fires. Sixthly, use ground fault circuit interrupters, or GFCIs, to protect against ground faults, which can cause electric shock. Seventhly, comply with all applicable codes and standards, including the NEC and local electrical codes. The NEC is updated every 3 years, so it is important to stay current with the latest requirements. Eighthly, hire a qualified electrician to design and install the electrical panel. A qualified electrician has the knowledge and experience to ensure that the electrical system is safe and reliable. Subpanels are often used to extend the capacity of an existing electrical panel. A subpanel is a smaller panel that is fed from the main panel. Subpanels can be used to serve specific areas of a building or to isolate certain loads. The NEC provides detailed requirements for the installation of subpanels, including the size of the feeder conductors, the grounding and bonding requirements, and the overcurrent protection requirements. Subpanels must be properly labeled to indicate that they are fed from the main panel. The location of the electrical panel is also an important consideration. The panel should be located in a readily accessible location that is free from obstructions. The panel should also be protected from physical damage. The NEC specifies minimum clearances around electrical panels to ensure that electricians have enough room to work safely. The panel should be mounted securely to a wall or other structure. The height of the panel should be such that the circuit breakers and fuses are easily accessible. The use of energy-efficient lighting and appliances can help to reduce the load on the electrical system. Energy-efficient lighting and appliances use less electricity than traditional lighting and appliances. This can save money on energy bills and reduce the risk of overloading the electrical system. The NEC provides guidelines on the selection and installation of energy-efficient lighting and appliances. The use of renewable energy sources, such as solar panels and wind turbines, can also help to reduce the load on the electrical system. Renewable energy sources generate electricity from renewable resources, such as sunlight and wind. This can reduce the reliance on fossil fuels and lower energy costs. The NEC provides guidelines on the installation of renewable energy systems. The coordination of overcurrent protection devices is important for ensuring that the electrical system operates safely and reliably. Overcurrent protection devices should be coordinated so that the device closest to the fault trips first, minimizing the extent of the outage. The NEC provides guidelines on the coordination of overcurrent protection devices. Short circuit studies are often performed to determine the available fault current at various points in the electrical system. The available fault current is the amount of current that would flow in the event of a short circuit. This information is used to select overcurrent protection devices with adequate interrupting ratings. The interrupting rating of an overcurrent protection device is the maximum amount of current that it can safely interrupt. Arc flash studies are performed to determine the potential arc flash hazards in the electrical system. Arc flash is a dangerous electrical explosion that can cause serious injury or death. Arc flash studies are used to determine the amount of protective clothing and equipment that workers must wear when working on energized equipment. The NEC provides guidelines on arc flash hazard assessments and arc flash protection. Power quality is an important consideration in electrical panel design. Poor power quality can lead to malfunctioning equipment, reduced energy efficiency, and increased maintenance costs. Power quality problems include voltage sags, voltage swells, harmonics, and transients. The NEC provides guidelines on power quality monitoring and mitigation. Harmonic filters can be used to reduce the levels of harmonics in the electrical system. Surge suppressors can be used to protect against voltage transients. Uninterruptible power supplies, or UPSs, can be used to provide backup power in the event of a power outage. Isolation transformers can be used to isolate sensitive equipment from the electrical system. The use of power monitoring equipment can help to identify and diagnose power quality problems. Power monitoring equipment can measure voltage, current, frequency, harmonics, and other power quality parameters. The data collected by power monitoring equipment can be used to improve the performance and reliability of the electrical system. The NEC provides guidelines on power monitoring and analysis. The integration of smart grid technologies into electrical panels is becoming increasingly common. Smart grid technologies include smart meters, smart appliances, and advanced control systems. These technologies can help to improve energy efficiency, reduce energy costs, and enhance grid reliability. The NEC provides guidelines on the installation of smart grid technologies. The use of communication networks in electrical panels is also becoming more common. Communication networks can be used to monitor and control electrical equipment, collect data, and provide remote access to the electrical system. The NEC provides guidelines on the installation of communication networks in electrical panels. The use of wireless technologies in electrical panels is also becoming more prevalent. Wireless technologies can be used to connect sensors, meters, and other devices to the electrical system. The NEC provides guidelines on the installation of wireless technologies in electrical panels. The use of cloud-based services for electrical panel monitoring and control is also emerging. Cloud-based services can provide remote access to electrical system data, allow for remote control of electrical equipment, and provide advanced analytics capabilities. The NEC is likely to address cloud-based services in future editions. The aging infrastructure of electrical systems is a growing concern. Many electrical systems are reaching the end of their useful life and need to be replaced or upgraded. The NEC provides guidelines on the replacement and upgrading of electrical systems. The use of new materials and technologies in electrical panels can help to improve their performance, reliability, and safety. For example, the use of solid-state circuit breakers can provide faster and more reliable protection than traditional electromechanical circuit breakers. The use of new insulation materials can provide better protection against electrical shock. The NEC is constantly evolving to keep pace with new technologies and materials. The training and certification of electricians is essential for ensuring that electrical work is performed safely and correctly. Electricians should be trained in the latest codes and standards, as well as in the proper techniques for installing, maintaining, and repairing electrical systems. The NEC recommends that electricians be certified by a recognized organization. The enforcement of electrical codes is crucial for ensuring that electrical systems are installed and maintained in accordance with safety standards. Electrical inspectors are responsible for enforcing electrical codes. Electrical inspectors review electrical plans, inspect electrical installations, and issue permits. The NEC recommends that electrical inspectors be certified by a recognized organization. Public education on electrical safety is important for preventing electrical accidents. The public should be educated on the hazards of electricity and on the steps that can be taken to prevent electrical shock, fires, and other electrical accidents. The NEC recommends that public education programs be conducted on electrical safety. Standardization of electrical equipment and practices is important for ensuring interoperability and safety. The NEC promotes the standardization of electrical equipment and practices. The development of new electrical codes and standards is an ongoing process. The NEC is updated every 3 years to reflect new technologies, materials, and practices. The NEC is developed by a committee of experts from various fields including electrical engineering, electrical contracting, and electrical inspection. International collaboration on electrical codes and standards is becoming increasingly important. The International Electrotechnical Commission, or IC, is an international organization that develops electrical codes and standards. The NEC is often harmonized with IEC standards. The future of electrical panels is likely to be characterized by increased intelligence, connectivity, and automation. Electrical panels will be equipped with sensors, meters, and control systems that can monitor and manage energy consumption, detect faults, and optimize performance. Electrical panels will be connected to the internet and to other devices, allowing for remote monitoring and control. Electrical panels will be automated to perform tasks such as load shedding, peak shaving, and demand response. The NEC will continue to evolve to address these new technologies and trends.